In the last part of this video, I mentioned that a hypothesis test leads to an inference, and it doesn't lead to a sure conclusion. And I think a good analogy for a hypothesis test is a jury trial. So in a jury trial, um, you want to know if a person committed a crime, and there are two possibilities. There's a possibility that the person is innocent and nothing is happening, and the possibility that the person did commit the crime and they're guilty. And those are the null and alternative hypothesis of the jury trial. And the jury is either going to convict the person or to acquit the person and let the person go free. And if the jury convicts the person, the jury is saying, based on the evidence that we have, I'm confident that something is happening other than just chance, and I'm confident that the person did actually commit the crime. That's rejecting the null hypothesis. So in the jury analogy, a conviction is rejecting the null hypothesis, rejecting the null hypothesis of innocence. If the jury acquits the person, the jury is saying that the evidence isn't strong enough, so we're going to assume that the person is innocent. That is retaining the null hypothesis of innocence. But when a jury convicts or acquits a person, it's just an inference. It's not a sure conclusion because it's possible to send an innocent person to jail, and it's possible to let a guilty person go free. So in a hypothesis test, the same thing is true. It's possible to reject the null and be wrong, or to retain the null and be wrong. So in a hypothesis test, uh, all you're saying is, based on the data I have, I'm confident that this is the truth, but I'm not 100% sure. And the two possible wrong conclusions have a name. They're called a type 1 error and a type 2 error. A type 1 error is rejecting the null hypothesis when it's true, and type 2 error is retaining the null hypothesis when it's false. So when you make a type 1 error, you've rejected something that shouldn't be rejected, and a type 2 error, you've retained something that shouldn't be retained. And so in the jury analogy, sending an innocent person to jail is a type 1 error because you've rejected the null hypothesis and you've said, I'm confident that something is happening, but really nothing is happening. That's a type 1 error. Letting a guilty person go free is a type 2 error because it's when the jury um, decides to assume that nothing is happening, but really something is actually happening. So a type 1 error is basically a false alarm, and a type 2 error is a miss. It's when a type 2 error is when something is happening, but it just slips by you and you don't pick up on it, basically. And let's go back to a couple of my everyday life examples and see if we can apply these concepts to those examples. So let's go back to the car trouble example. So imagine you're sitting in your car and you hear a noise, and imagine you think, I'm having car trouble, and in reality, you're not having car trouble and you just hit a bump in the road by chance. Well, that's a type 1 error. That's a false alarm. You've decided that something is happening, but really nothing is happening. And so what you've done is you've rejected the null hypothesis of no car trouble. You've thrown that out, and you're actually wrong because really the null is true. Nothing is happening, and you've rejected it wrongly. That's type 1 error, false alarm. Now imagine you're sitting in your car and you hear the noise from the engine, and you think, well, it's just one noise, so it could just be a bump in the road. So I'm not worried that anything is happening, and I'm just going to assume that my car is fine. But let's say the truth is that you are having car trouble, and the noise didn't happen just by chance. Well, that's a type 2 error. That's a miss. Something has slipped by you you've because something really is going on, and you just didn't pick up on any convincing evidence for it, and you just assumed that it's not happening. So yeah, a type 1 error is when you gather data, and your data leads you to conclude that something is happening when really nothing is happening, and it's a false alarm. A type 2 error is when something is actually happening, the null is false, but your data simply doesn't pick up on enough evidence for it, and you just say, based on my data, I'm assuming that nothing is happening, but really something is actually happening. That's type 2 error. So remember, type 1 error, false alarm, type 2 error is a miss. Now let's go through a few examples and see if we can like apply these concepts to specific like realistic data collection situations. So imagine that that a person wants to know if working college students tend to be sleep deprived compared to non-working students. The person gathers data, and the person's conclusion is, my data suggests that working college students are sleep deprived. So notice how this person has rejected the null hypothesis. The person has said, based on my data, I'm confident that something is happening and that my data isn't just due to chance. I'm confident that there is actually sleep deprivation in this population. But let's say that the reality is that working college students aren't more sleep deprived on average. The reality is that they're equal to non-working students on average. Well, that would be a type 1 error because the researcher concluded that something is happening when in reality that is not actually happening. So that would be a type 1 error, false alarm. Now imagine that a person wants to know if there's a difference in self-esteem between social media users and non-users, and the person gathers some data and looks at the data, and the person concludes that I'm confident that there is a relationship between social media use and self-esteem in the college student population. But let's imagine that in reality, that there's actually no relationship, um, and that users and non-users are actually equal on average. Well, that would be a type 1 error. That's another false alarm. And a type 1 error can occur if a type 1 error can occur if you end up getting some extreme or unusual people in your sample just by chance. So here's an example. Let's imagine that I want to know if working college students tend to be sleep deprived, and I go out and I ask, let's say, 30 working students, how much sleep do you get per night typically? And I ask 30 non-working students, how much sleep do you get per night typically? And let's imagine that I calculate the two means. I calculate the mean of my 30 working students and the mean of my 30 non-working students. And let's imagine that the mean of the 30 working students comes out to 5.7 hours, which is a little low. And imagine that the mean of the 30 non-working comes out to 7.5. So imagine my two means have come out to 5.7 and 7.5. And imagine that based on that outcome, I conclude that I'm confident that working students tend to be more sleep deprived because their average was 5.7. Well, I could be wrong because remember, I've only sampled 30 and 30. I haven't surveyed all working students and I haven't surveyed all non-working students that are out there. So it could be that mean of 5.7 it just has to do with the specific 30 people that I sampled. So it could be that working students are actually not really that sleep deprived, but I just happened to get a bunch of tired working students in my sample by chance, and that's why their average was down at 5.7. It could be that just by chance I happened to grab a bunch of tired working students who were tired for other reasons. And if that did happen, I have a type 1 error because my data led me to conclude something, and the truth is that there's actually nothing out there. There's nothing really going on. So like I said, a type 1 error can happen if you happen to get some kind of unusual or non-representative people in your data just by chance. Now let's look at some examples of type 2 error. So let's imagine that a person gathers some data and the person concludes that there isn't enough evidence in my data set to conclude that working college students are sleep deprived. And that's retaining the null hypothesis. And let's also imagine that the reality is that working students do actually tend to be sleep deprived, and the data set simply didn't show it. The data didn't pick up on it. Well, that would be a type 2 error because something is actually happening, but the data simply failed to pick up on it. The data failed to show any convincing evidence for it. Here's another example of type 2 error. Let's imagine that a person says, based on my data, there isn't enough evidence to conclude that social media use and self-esteem are correlated. But in reality, let's say that they are actually correlated. Well, that would be a type 2 error because something is true and the data simply failed to show it. And just like a type 1 error, a type 2 error can happen when there's some non-representative or unusual people in the sample simply by chance. So it could be that the people who use social media do tend to be low in self-esteem, but the person who's collecting data doesn't get any of those people in the sample. Simply by chance, the person doesn't get any of those low self-esteem individuals into the sample, and the sample only includes people who are high in self-esteem. So if let's say by chance the sample only includes people who are high in self-esteem, and the reality is that there are a lot of people out there who use social media and are low in self-esteem, then that would cause a type 2 error because those people are actually out there, but simply none of them ended up in the sample and none of them were observed. That's a type 2 error because that's, like I said, it's like a miss. Something is actually out there, but you simply missed it. You didn't end up observing it. So that's type 1 error and type 2 error. Now let's cover a few bullet points about type 1 and type 2 errors. So they happen a certain percentage of the time in research studies, even when the studies are done well. So you can't eliminate these errors, but the goal is to minimize them. So if research and data collection is done well, then these errors will only happen a small percentage of the time. And if research is done poorly, they'll happen more often. So like I said, the goal is to minimize them. And they occur when random sampling fails to give a representative sample. So like I said, if you do random sampling and you get a non-representative or kind of unusual sample simply by chance, that's going to lead you to a type 1 error or a type 2 error. It will lead you to either wrongly say that something is happening or to wrongly assume that nothing is happening. And when a type 1 or type 2 error occurs, it isn't necessarily the researcher's fault. It doesn't mean that the data collection was done poorly because, like I said, it can happen when random sampling simply fails to do its job. So random sampling does its job pretty well typically. It's pretty reliable at giving a good sample, but random sampling fails from time to time. And when it does fail, you get a type 1 or type 2 error. And also, well, from this point on in our class, each hypothesis test that we run has a checklist of requirements that has to be met in order to be able to run that hypothesis test. So you might remember how when we were calculating confidence intervals, we would have a checklist that would have to be checked off before we could move forward. In a hypothesis test, there's also a checklist that has to be checked off before running the test. And if if that checklist isn't met and you go ahead and do the test anyway, you're more likely to make either a type 1 or type 2 error because your test isn't actually valid. And just a few more points here about type 1 and type 2 errors. So a type 2 error is more likely when the sample size is small. That's because when you collect a small amount of data, you're more likely to miss something that is actually out there. So, um, so imagine that I want to know if I'm interested in if people who use social media tend to be lower in self-esteem, and I ask two people, how much social media do you use, and what's your level of self-esteem, and I survey those two people only. And imagine that those two people both tell me that they use social media, and they both tell me that they're high in self-esteem. Well, my data isn't show if that's the case, my data isn't showing any evidence um, for a tendency for social media users to be low in self-esteem. But it could be that there are a lot of social media users out there who are actually low in self-esteem, but I simply didn't observe any of them because I only surveyed two people. So like I said, when you have a small sample, you're more likely to miss something that is actually out there. That's why a type 2 error is more likely when the sample size is small. Um, the the type 1 error probability is actually controlled by the hypothesis test. And we'll actually, you'll see what I mean once we get to some examples, but when you do a hypothesis test, you actually set the probability of a type 1 error to a fixed level in advance, and it's usually set to 0.05. So you might remember when you create a confidence interval that you set your confidence level in advance before you actually run the formula. For example, you set it to 95 or 99. In a hypothesis test, you set the type 1 error probability in advance also. So it's controlled by the hypothesis test. And 0.05 is what people usually agree on, is what it should be set to. And now let's quickly talk about the steps of hypothesis test. When we go forward in this class and we talk about specific examples of hypothesis testing, um, you'll see that each hypothesis test has its own formula, and each hypothesis test is designed to answer a certain type of question, but all of the hypothesis tests that we'll cover follow the same general steps. And right now I'm just covering those general steps. So first you have to know what you're testing. So you set up your null and your alternative, you state them, then you take your random sample and you collect your data. Then you calculate something called a test statistic. And the formula that you use to calculate the test statistic depends on what test you're running. And the test statistic measures the strength of the evidence against your null hypothesis. So if the test statistic comes out to a big number, you're confident that the null is false and that something is happening. And then you check if your test statistic reached a cutoff point called a critical value. And if the test statistic is at the critical value or higher, you reject the null hypothesis. If the test statistic falls below the critical value, you retain the null hypothesis because in that case, your data isn't showing strong enough evidence. And basically the test statistic is what leads you to either reject or retain the null hypothesis, to one or the other, because like I said, if the test statistic reaches the critical value, reject. If it doesn't reach, retain. And after you make your decision to reject or retain the null hypothesis, you'll have a more specific conclusion in the context of the question that you were hoping to answer. So you'll also have a conclusion that that fits into the context of the whatever question you were hoping to answer in the first place. And that's our intro to hypothesis testing. In the next topic, we'll get into the two-sample t-test, which is our first actual hypothesis test that we'll cover in detail.